All right, welcome to part two of parabolas and talking about conic sections. We're leaving off on the previous example where we were looking for the directrix, vertex, and the focus. So in part two, or in example B, what are the vertex, focus, and directrix of the parabola with the equation x equals 3/4 y squared? Now, since we have x in terms of y, you can look at this and say, well, this would be a horizontal parabola. So, in order to identify the vertex, focus, and directrix, number one, since we have this type of equation, I haven't shown you any other type, we know the vertex is going to be at 0, 0, or the origin. Okay, so number one, I'm going to identify A. In this case, A is equal to 3/4. Okay, with our formula, we know that this value, 3/4, is equal to 1 over 4c. It's important to note that the numerators are not equal here. Okay, very important. The last time in the example we had 1/4 c equals 1 over 12, negative 1/12, and we set the denominators equal to one another. In this case we can't. C does not equal 1. So what we have to do is take this fraction, 3/4, and write it 1 over 3/4, or 1 divided by 0.75. Then we have 1 over a number, 1 over a number. So we're going to have 4c is equal to 1 over 0.75. Solving for c, we get 1/3. Now, since we have c equals 1/3, we know our focus. Our focus is 1/3 comma 0, which means our directrix is the vertical line x equals negative 1/3, and our vertex is 0, 0. So just be very careful of when you're solving for c, and if we don't have the two fractions or the two ratios here they're equal to one another, but we need to set the second fraction to 1 over this. You could also use proportions and cross multiply to find c. Okay, so what this slide says just it summarizes what we're talking about. The first vertical column is all the examples we did, and then the second column is when we have a vertex that's other than 0, 0. So we have the vertical parabola and the horizontal parabola, the equation, the focus, and directrix of each for the vertex equaling 0 and the vertex equaling something other than 0, 0. So we've already talked about all these, but let's kind of pay attention to what happens when we change the center of the parabola. The vertex is going from 0, 0 to hk. The equation when you have a vertical parabola becomes 1 over 4c times the quantity x minus h squared plus k. Your focus is no longer 0c, but h comma k plus c. So that changes. The directrix is no longer y equals negative c when the vertex is at the origin, but becomes y equals k minus c. Okay, so be very aware of those formulas. You're going to have to know those. When we have the horizontal parabola, remember we had x in terms of y. We had a focus at c0, and we had a directrix at x equals negative c. That does change when we get to an h and k value that's not 0, 0. The equation becomes x equals 1 over 4c times the quantity y minus k squared plus h. The focus is h plus c comma 0, and the directrix is x equals h minus c. Okay? In our last couple slides, we just wanted to show you an example of what happens when you have a vertex that's not the center. In problem number 3, what are the vertex, focus, and directrix of the parabola y equals x squared minus 4x plus 8, a standard form parabola? So, in order to do that, you need to know h and k, you need to know c, and that's what we've got to be looking for. But if we graph this, you can see that we don't know what the vertex is. And so we're going to actually change this into vertex form, and to do that, to change this parabola into vertex form, we're going to complete the square. So here's my parabola, okay? And to complete the square, I take half of the b term and square it. So that's what I've done here. And I've left the 8 on the outside. Okay, but to keep this parabola the same, I added 4 here, so now with the 8 I actually have to subtract 4 because I have to keep this quadratic the same. If I add 4 and then add 4 out here, I've changed the entire parabola. So if I add 4 to the right side, I also have to take away 4 on that right side to keep the parabola the same, keep the equation the same. So I do that. So remember, we complete the square. That's what you see in parentheses here. And two numbers that multiply to be 4 and add to be -4 are -2 and -2. So you have x minus 2 squared plus 4. Okay, so the vertex is going to be at 2 and 4. Okay, 8 minus 4 is 4, so that's 2 and 4. And notice, I want you to pay attention, the number in front of this vertex form is 1. So let's look at finding the focus and the directrix. So I made note of that 1 over 4, the A term, 1 over 4c is equal to 1 because of this equation. A times the quantity x minus h squared plus k. So there's our vertex form. We know that 1 over 4c is going to equal to 1 because the number in front was equal to 1. So we know that c is 1/4 when we solve for c. H and k, 2, 4 is our vertex. So the focus is h, comma, k plus c. So by substitution, h was 2, comma, k is 4, plus c. So your focus is 2, comma, 4.25. It's important to remember that the directrix is not just the opposite sign now. The directrix is equal to k minus c. K is 4, c was 1/4. So you get 3.75 for the directrix. Okay, so again, when you have a standard form parabola and you're looking for the focus, the directrix, use completing the square. Okay, be very careful on how you identify A. Look at the number in front of the quantity being squared. That coefficient is going to be equal to 1 over 4c. And just remember your equations for the focus and the directrix. If you guys have any questions on this second part, go ahead and put the questions below on the YouTube page, or you can email me. Thanks.